Hello everyone, my name is Aditya Maurya and today I will discuss artificial neural network. So these are the contents that will be discussed in this video. So first of all, introduction, then biological neuron model, then artificial neuron model, artificial neural network architecture, learning, backpropagation algorithm, then applications, then advantages, then conclusion. So let's start. So, introduction. Neural is an adjective for neuron, and network denotes a graph-like structure. So, artificial neural networks are also referred to as neural nets, artificial neural systems, parallel distributed processing systems, connectionist systems. For a computing systems to be called by these pretty names, it is necessary for the system to have a label-directed graph structure where nodes perform some simple computations. So directed graph consists of a set of nodes and a set of connections connecting pair of nodes. A graph is said to be labeled graph if each connection is associated with a label to identify some property of the connection. So here there are two figures. First shows AND gate graph and second shows AND gate network. So AND gate graph, this graph cannot be considered a neural network since the connections between the nodes are fixed and appear to play no other role than carrying the inputs to the node that computed their conjunction. And gate network, the graph structure which connects the weights modifiable using a learning algorithm qualifies the computing system to be called an artificial neural networks. So the field of neural network was pioneered by Bernard Vidro of Stephen University in 1950s. So this is the diagram of biological neuron model. Now four parts of a typical nerve cell. First, dendrites, that is uh, that accepts the inputs, and soma, which process the inputs, and axon, it turns the processed inputs into outputs, and synapses, the electrochemical contact between the neurons. Now, artificial neuron model. Inputs to the network are represented by the mathematical symbol xn. Each of these inputs are multiplied by a connection weight wn. So sum is equal to w1 x1 plus that is wn xn, as you can see in that diagram. Now these products are simply summed fed through the transfer function to generate a result and then output. Now this is the these are the terminologies which are belongs to biological terminology and artificial neural network terminology. So in biological terminology, neuron, synapse, synaptic efficiency, firing frequency, and if we talk about artificial neural network terminology, so node, unit, cell, neuron, and connection, edge link, connection strength, weight, and node output. Now, artificial neural network. Artificial neural network (NNs) are programs designed to solve any problem by trying to mimic the structure and the function of our nervous system. So, neural networks are based on simulated neurons which are joined together in a variety of ways to form networks. Neural network resembles the human brain in the following two ways. A neural network acquires knowledge through learning, and second, a neural network's knowledge is stored within the interconnection instance known as synaptic weight. Now these are the artificial neural network model. As you can see, uh, first one is artificial neural network model and second figure showing edges of neural networks. Now these are the neural network architectures. First one is fully connected network, and second figure shows layered network. So if we talk about fully connected network, so it is nothing but it is the natural network in which every node is connected to every other nodes, and these connections may be either excitatory, uh, that is positive waves, inhibitory, that is negative waves, or irrelevant, that is almost zero waves. Okay, so now layered network. These are networks in which nodes are partitioned into subsets called layers with no connections from layer j to k if j greater than k, as you can see in the figure. Now these are the figures that shows acyclic network and feed forward network. So if we talk about acyclic network, this is a subclass of the layered networks in which there is no intra-layer connections. In other words, a connection may exist between any node in layer I and any node in layer j for I less than j, but a connection is not allowed for I is equal to j. This is a subclass of acyclic networks in which a connection is allowed from a node in layer I only to nodes in layer I plus 1. Now this figure shows modular neural network. What is modular neural network? Many problems are best solved using neural networks whose architecture consists of several modules with sparse interconnections between them. Modules can be organized in several different ways as hierarchical organization, successive refinement, input modularity. Now, learning. Neurons in an animal's brain are hardwired. It is equally obvious the animals, especially higher order animals, learn as they grow. How does this learning occur? What are possible mathematical models of learning? In artificial neural networks, learning refers to the method of modifying the weights of connections between the nodes of a specified network. The learning ability of a neural network is determined by its architecture and by the algorithmic method chosen for training. Now, here we can see the difference between supervised learning and unsupervised learning. So, in supervised learning, a teacher is available to indicate whether a system is performing correctly or to indicate the amount of error in system performance. Here, a teacher is a set of training data, and if we talk about unsupervised learning, this is learning by doing. Now, in supervised learning, the training data consists of pairs of input and desired output values that are traditionally represented in data vectors. And in supervised learning, uh, no sample outputs are provided to the network against which it can measure its predictive performance for a given vector of inputs. In supervised learning, it can also be referred as classification, where we have a wide range of classifiers, that is multi-layer perceptron, k-nearest neighbor, etc. And in unsupervised learning, one common form of unsupervised learning is clustering, where we try to categorize data in different clusters by their similarity. Now, the backpropagation algorithm. So, the backpropagation algorithm, uh, Rumelhart and McClelland 1986, is used in layered feed-forward artificial neural networks. Now, backpropagation is a multi-layer feed-forward supervised learning network based on gradient descent learning rule. We provide the algorithm with examples of the inputs and outputs we want the network to compute, and then the error difference between actual and expected results is calculated. The idea of the backpropagation algorithm is to reduce this error until the artificial neural network learns the training data. Now, the activation function of the artificial neurons in NNs implementing the backpropagation algorithm is a weighted sum, that is the sum of the inputs xi multiplied by their respective weights wji, as you can see in this page. The most common output function is the sigmoidal function, as you can see here. Now the error is the difference between the actual and the desired output. The error depends on the weights, and we need to adjust the weights in order to minimize the error. We can define the error function for the output of the each neuron. So this figure shows basic block of back propagation neural network, as you can see here. Now the propagation algorithm now calculates how the error depends on the output, inputs and weights. The adjustment of each weight delta wji will be the negative of a constant eta multiplied by the dependence of the wji previous weight on the error of the network. First, we need to calculate how much the error depends on the output. Next, how much the output depends on the activation, which in turn depends on the weights. And so the adjustment to each weight will be. Now, if we want to adjust VIK, the weights, let's call them VIK of a previous layer, we need first to calculate how the error depends not on the weight but in the input from the previous layer, that is replacing W by X as shown in below equation. So as you can see here, now these are some applications of neural network. Now advantages of artificial neural network: it involves human-like thinking, they handle noisy or missing data, they can work with large number of variables or parameters, they provide general solutions with good predictive accuracy, system has got property of continuous learning, they deal with the non-linearity in the world in which we live. So thank you.